This is the fifth and final section of chapter 7, and this section is on hypothesis testing for the difference between means. So one of the things we need to do if we're going to do a hypothesis test for the difference between two means is we need to calculate our test statistic. And obviously, first of all, you'd write down H0 and H1, then we'd find a critical value. We'll look at that in a moment. And this is our test statistic. This is the calculation that we need to do here. So this part here is going to be the pooled standard deviation. So it's going to be the square root of this calculation, which we did in the previous section. And if our H0 is that the means are equal to one another, then this calculation here, this part is going to be 0. So remember, the population means themselves are not known. Now, if our H0 was instead that, let's say that the difference between the means was less than 10 or a maximum of 10, then when we get to do this part here, then this would be minus 10, the actual difference, the maximum difference that we're allowing between our means. And then, as I said before, we want to find our critical value or values from the t-distribution table. Critical values, if it's a two-tailed test, well, you just look at one value and you stick a minus sign in front. So the critical value we're going to find by working out the degrees of freedom, which is the same as this value, the number in each sample added together, minus 2, and then a significance level here. I'll just put an example there, 5% for example, and I'll always draw a diagram so you can see if your test statistic is in the critical region. That helps you make the right decision at the end and write the right conclusion. Example 12. Two groups of students, X and Y, were taught by different teachers. At the end of their course, a random sample of students from each class was selected and given a test. The test results out of 50 were as follows. Okay, so this is group X here, this is group Y here. The head teacher wishes to find out if there is a significant difference between the test or between the results for each of these two groups. Part A is asking us to write down any assumptions that need to be made in order to conduct a difference of mean test on this data. Okay, so I've changed my mind and put my answer up here. So assumptions are that the marks are normally distributed, the marks are independent, and the variances of the two classes are equal. Part B, assuming that these assumptions apply, test at the 10% level of significance whether or not there is a significance difference between the means. So we start with H0 and H1. So it's groups X and Y, so we'll talk about mean X and the mean Y. So we'll say that those means are equal, and then H1 will be that the means are not equal. So we're looking at a two-tailed test, and we're going to split this significance level to 5% two-tail. So we split the 10%, we're going to have 5% in each tail. So now we'll find our critical values before we do our test statistic. So you're going to have 0 here, t-distribution. So the number of degrees of freedom is going to be the number in each of the two classes. How much have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you've got 9 here. In the second class, 1, 2, 3, 4, 5, 6, 7. So degrees of freedom is going to be 9 plus 7 minus 2. So that's going to be 14. So it's a t-distribution with 14 degrees of freedom. Two-tailed test. So we're looking for 5% to find what these critical values are on the left and the right. So from the table, 1.761 and then negative 1.761. So these are our critical regions here in our tails. So what we're basically saying is we don't want the difference between these means to be any more than what's in this middle section here. If the difference lies outside of that range, then it means our test is significant, and then we'd go about rejecting H0 and so on. So let's now work out our test statistic. So here are the two formulas I'm going to use for my test statistic here, and then to find the pooled standard deviation I need to find the square root of this. So I can see that I'm going to need nx, ny, mean of x, mean of y, variance of x, and the variance of y. So let's work those out now using our calculator. So here's the number in the sample for x, the mean of x, the standard deviation of x. I'll square root that in a moment for this formula here, and the same for my sample y, group y. Okay, so that gives us 19.95898. Right, so now that can go, well, when we square root it, it can go here, so we can now get our value of t, zero where it is on here, then come up with our conclusion. Okay, so here's the numbers substituted here. I know it's very, very small, sorry about that. So here's my mean of x, 38.6 recurring, minus my mean of y, 40.2857. That's the value here, minus the difference between the means. We're assuming they're equal, so it's going to be 0. Then here I've got the square root of my pooled variance here. So this is 19.95898 number, square root of that to get the standard deviation, times by the square roots I've got to this bit here, 1 over 9 plus 1 over 7. That gives me a value of negative 0.71911 and so on. Now remember previously we said that the mean should be the larger mean should go first to avoid giving a negative. Well, in this case it doesn't really matter. I mean, they've told us that x is the first group. We end up with a negative, but whether it's positive or negative, we just want to know whether or not it's in the critical region. So if I had these the other way around, I'd have a positive answer. I would still come up with the same conclusion because this is a two-tailed test. Now, negative 0.71911 is not in the critical region. It is a negative number, so it's going to be like maybe over here somewhere. So it's not significant, not in the critical region. If that were a positive and these were swapped with a larger mean first, it would be over this side. Still the same conclusion. The difference between the means is not significant. So based on that, we can write a conclusion. Since our critical value, basically I've said here, is in the critical region, it's greater than this negative value, it's less than this positive value, it is not significant, we'd accept H0. There's insufficient evidence to show that the means are different, or that there is a difference between the means. Example 13, and in fact the very last example of further statistic 2. A random sample of the heights in centimetres of 6th form boys and girls was taken with the following results. So here the height of the boys, here's the height of the girls. Part A, we need to carry out a 2-sample t-test at the 5% significance level on these data to see whether the mean of the heights of the two boys exceeds the mean height of the girls by more than 4 centimetres. So we're not asked to show whether they're equal here, but whether the mean of the boys and the means of the girls, or the boys exceeds the girls by more than 4 centimetres. So here I'm making the boys the X population and the girls the Y population, because I'm expecting the boys to have a greater mean. So that's going to give me a positive. So the mean of the boys is equal to the mean of the girls plus 4. So if I add 4 to the height of the girls, I get the height of the boys. That would be H0. Okay, that actually it is 4 centimetres more than the height of the boys. Whereas for H1, I want to show that the mean height of the boys is more than 4 centimeters than the girls. So I can see that this is going to be a one-tailed test. We'll work out our degrees of freedom. So we have 1, 2, 3, 4, 5, 6, 7, 8 in our X population sample, and we have 1, 2, 3, 4, 5, 6, 7 in our girls or Y population sample. So degrees of freedom 8 plus 7 minus 2, 15 minus 2 is 13. So I'm going to find my critical value, 13 degrees of freedom, one tail test 5%, so we'll look that up in a table, and that is 1.771. I'm going to draw my little graph here so that I can clearly see where my value is going to be, and my critical value here is 1.771. So I've got the formulas I'm going to use over here. I need to calculate my pooled variance first, square root it and put it in here so that I can work out my test statistic, and then I can work out where it is, then I can come up with my conclusion. So let's now write down the values that I need: n sub x, n sub y, the standard deviation or the variance of my samples, and the mean of my samples. Right, so here's all the values that I need here. So let's work out now our pooled variance. So it's going to be nx minus 1, 7, times by that squared, so 6.8230 squared, plus n sub y minus 1, so it's going to be 6 times by this standard deviation squared, so 7.6095 squared, and then all of that divided by 8 plus 7 minus 2. So that gives me 51.7923. Now I can work out my test statistics. So the mean of x, 148.375, minus the mean of y, 136.714, and then there's the 285, minus. Now if I subtract one mean from the other, basically the means are equal, I'm left with 4. So just minus 4, and then all divided by the square root of this, so I give me my pooled standard deviation, so 51.7923 square rooted, and times by the square root of 1 over 8 plus 1 over 7, and that gives me 2.0567. So on my diagram I can see that is significant, because that's going to be in the critical region. So let me now put my conclusion up the top here. So my conclusion, you can word it differently. So since my critical value or my test statistic is greater than the critical value, it is significant. Therefore the evidence suggests the boys exceed the girls' height by more than 4 centimeters, or the mean height of the boys exceeds the mean height of the girls by more than 4 centimeters. And then part B, asks here, state any assumptions that you have made. So the assumptions that I've made are that the heights of the boys and the girls are both normally distributed. The samples are independent, so I didn't pick all tall boys or short girls or vice versa. And that the variances are equal. Okay, so heights normally distributed, samples independent, maybe I should put bullet points before these, So one here, one here, one here. Here, samples independent and the variance is equal. They're the assumptions that I've made. So you should now be able to do exercise 7E on pages 187 to 189 of the textbook, and congratulations, you have now finished Further Statistics 2.